Hello, and welcome to Backer Breaks It Down. In this episode, we're going to look at complementary angles. In fact, we're actually going to prove that two angles are complementary. Exciting stuff. Let's get started. So on your reasons sheet, you have definition of complementary angles. And the definition of complementary angles says, if the sum of two angles is a right angle, then they are complementary. So this sets up a pattern that we will follow when we formally prove two angles are complementary, okay? So first off, the definition says if the sum of two angles is a right angle. So we need a right angle. And then we need to show that the sum of two angles is that right angle. And so we're going to use something called the angle addition postulate to show that. And then finally, we can say that the two angles are complementary via the definition of complementary angles. So let's see such a proof, okay? So the definition says that the very first thing we need is a right angle. And so look at that. That's exactly what we're given. All right. So step one is that angle TVK is a right angle. And our reason for that is that it was given. Okay. So I'm trying to prove that angle 1 is complementary to angle 2. And the definition says I need to show that the sum of two angles is a right angle. So that brings me to the second step in our pattern, the angle addition postulate. So I'm actually going to put into my proof that if I were to add angle 1 and angle 2, I would get the entire angle TBK. So I'm going to write it like this. So I'm going to say M angle 1 for the measure of angle 1 plus M angle 2, the measure of angle 2, equals the measure of angle TVK. And this is the angle addition postulate. If I add the two smaller angles together, I get the whole big angle. So here in step 2, what I have is that the sum of two angles is a right angle. Remember in step 1, I said angle TBK was a right angle. Therefore, it follows that the two angles are complementary. So then I can say, I would love to have a pen here. I can say in step 3 that angle 1 is complementary to angle 2 according to the definition of complementary angles. So it's all there. I have the right angle because that's what I was given. In my second step, I used the angle addition postulate to show that the sum, that's nice, of two angles is my right angle. And then in step 3, I was able to say that they were complementary. So let's apply the definition of complementary angles right here. So we are given that angle A and angle B are complementary. So what I know, according to the definition, is that the sum of those two angles will be equal to a right angle, and I know a right angle is 90 degrees. Now, they told me that the measure of angle A is equal to 3x plus 7, and that the measure of angle B is equal to 6x plus 11. So I'm using my angle addition postulate to create an equation here using the definition of complementary. The rest is a matter of some really amazing algebra skills of mine. Let's see if I can, prove those skills here. So I have 9x plus 18 is 90. And so then I get 9x is equal to, what is that, 72. Therefore, x is equal to 8. Okay, now be careful because in geometry, rarely is the value of x our final answer. Always go and look back and see what did they want. And it said determine the measure of each angle. So since I know that x is 8, I'm going to substitute that into each of these expressions, divine the measure of each of my angles. Therefore, the measure of angle A, we have 31 degrees, and then the measure of angle B would be, what is that, 59 degrees? Okay, and there you have it. There's the definition of complementary angles. If the sum of two angles is a right angle, then the two angles are complementary. You've seen how we can prove that, and you see how we can apply that. And that's how Becker breaks it down.